Okay folks, so welcome to today's video. It's a quick revision recap on ionic and covalent bonding. It's not going to be an in-depth look at not going to go into the properties and whether they conduct electricity or the melting points and boiling points or structures or things like that. It's just going to be a light touch revision video on what they actually are and what the electrons actually do for these bondings. And some of you might have noticed we've had an increase in our production budget, so we've now got coloured pens. Ooh, Hollywood, here we come. So the first thing to look at when we talk about bonding is it's all about electrons and, more importantly, electronic configuration. So got chlorine here. So this is what you'd see if you looked at chlorine on the periodic table. 17 at the bottom, 35.5 at the top. All that we care about when we're talking about bonding, we're not interested in the mass number. We're just interested in that number. So I'm not going to go into loads of detail about it. For the purposes of this video, that tells you how many electrons it's got. So chlorine's got 17 electrons. What's electronic configuration mean? How they're configured, how they're arranged. So there's two ways of doing that. There's the shorthand way. So 2 electrons can fit on the first shell, then 8 electrons on the second. Well, we're not up to 17 yet, so we need another shell. So we'll stick 8 on that shell. And we're still not up to 17 yet, so 2 plus 8 is 10. We need 7 more, so 2, 8, 7. So that's a quick way of doing it. The slightly longer-winded way, but this is going to help us to understand bonding a bit more, would be to draw it. So we put Cl in the middle. First shell, we can fit 2 electrons on. Second shell, we can fit 8. And then the third shell, we can fit 7. Okay, so 2 ways of doing electronic configuration. And then that leads us on to the periodic table. So hopefully this is visible. Let's zoom in a little bit. So you've got the periodic table here, and so chlorine is just there, and so we said it had 7 electrons on its outer shell. Atoms want to have a full outer shell. Having a full outer shell makes them nice and stable. So that's what they strive to get. They really want a full outer shell. So chlorine isn't stable because it's only got 7 on its outer shell, so it's got space for 1 more. Periodic table helps you work that out really, really quickly. If you want to look at, it's just what groups they're in, which is the vertical columns. So that's group 1, that's group 2, ignore the middle bit, 3, 4, 5, 6, 7. So chlorine's in this column, it's in group 7, it's got 7 on its outer shell, which is what we just established there. So quick, easy way to you can use periodic table to cheat, basically. So if you had to do oxygen, you can draw it out, or you can go, oh, oxygen, it's in group 6, so it's got 6 on its outer shell. The other thing you need to know about the periodic table is to separate them out into metals and non-metals. So aluminium, hopefully most of you are aware that's a metal. Use that as your top step, and then draw a staircase going down. And everything on this side are the metals, and the bit in the top corner up here are the non-metals. And the last bit about the periodic table today is, if I can change the colour, when we're talking about bonding, you only need to know the first 20 elements. So you need to know down as far as calcium, and this is not, there we go, let's undo that. So you need to know down as far as calcium, which means you don't need to worry about any of these here. So for the purposes of GCSE chemistry, and drawing the bonding, you only need to worry about those 20. So you've got the metals over here, and then the non-metals over there. So first thing we're going to talk about is, in terms of bonding, is ionic bonding. So ionic bonding means it involves ions. And what's an ion? Well, an ion is an atom with a charge. Atoms don't have a charge overall because they're made of protons, which have a charge of +1, and they're made of electrons, which have a charge of -1. And atoms always have the same number of protons as they do electrons. So if we look at chlorine, it's got 17 protons and it's got 17 electrons. So it's got 17 electrons, so minus 17, and it's got 17 protons, so plus 17, and they cancel out, which give it an overall charge of 0. So the overall chlorine atom has no charge because it's got 17 pluses and 17 minuses. But an ion is an atom with a charge. So how do we give it a charge? We change the number of electrons it's got. So if you give an atom more electrons, you're giving it more negatives. So this confuses a lot of people, but once you get your brain around it, it makes sense. If you add a negative, you become more negative. So a lot of people think, well, if you're adding something, how can it make it negative? But if you're adding a negative, so minus 17, and we've added on minus 1, that makes minus 18. So even though we've added something, minus 17 plus minus 1 equals minus 18. And then same, if you lose an electron, you become positive because you're losing a negative. Just like in maths, if you minus a minus, if you have 1 minus minus 1, that equals 2, because it's the double negative. You're subtracting a negative, which is the same as a positive. Right, quick example of ionic bonding. So if we talk about lithium bonding, so lithium Li bonding with fluorine bonding with F. So we need to look at our periodic table. So lithium is over here. It's in group 1. So we know it's got 1 electron in its outer shell because it's in group 1. If you zoom in, I don't know if you can see that, lithium's got an atomic number of 3. So it's got 3 electrons and it's got 1 in its outer shell. And if we go over to fluorine, fluorine is in group 7 and it's got 9 electrons. So if I'm going to draw those just for a second. So we said lithium had 3 electrons. 1, 2, 3. And we had fluorine had 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 on its outer shell, 7 on its outer shell. Both of these are unstable because they want a full shell. Now lithium's got 2 options. It can either get 7 more on its outer shell to make it have 8. It's quite difficult to get 7 more, or it can just kick out 1 electron and then it would have a full shell. Fluorine, it can either lose 7, which is quite difficult to do, or it can gain 1. And that's exactly what happens. So this electron here goes to there. But we don't draw that. How do we draw that and how do we show that in chemistry is we just get rid of the outer shell. And I'll rub that a bit that I shouldn't. And we draw the electron over there. But we haven't quite finished because these aren't atoms anymore, they're ions. So we need to show something is an ion, we put a square bracket around it and we give it a charge. So lithium lost a negative, so you have to subtract a negative, so that makes it positive. So we would write +1. And fluorine has gained a negative, so we write it as -1. And that would be totally fine to write it that way. Scientists tend to be a bit lazy and they don't write a 1 where they don't have to. So when it's a -1, we just write a minus. So that's what you get when you have lithium bonded to fluorine. Why do they hang around together after they've done that? Because lithium's now given its electron away. Fluorine's gained it. Brilliant. Why do they carry on hanging around together? Well, because this one is positive and this one is negative, so they're attracted together by the electrostatic forces. The positive and negative opposite charges attract each other. So let's look at another example of ionic bonding. Beryllium and oxygen. So, oxygen here on a periodic table. Oxygen, it's got 8 electrons and it's in group 6. So we know it's going to have 6 on its outer shell. And beryllium, it's in group 2 and it's got 4 electrons, so it's in group 2, so it's got 2 on its outer shell. So when we draw these, we've got beryllium, 1, 2, 3, 4, 2 on its outer shell because it's in group 2, and oxygen, it's in group 6, so it's got 6 on its outer shell. And again, what happens? Beryllium gives away 2 electrons, oxygen gains 2 electrons. So we rub out the shell. The 2 electrons from beryllium have gone over here. I'm drawing it in colour so it's easy to see, but when you draw these, you just use dots and crosses. So the dots and crosses are exactly the same. They represent electrons. You could have drawn this one with crosses and this one with dots, but it just shows that the dots on here originally belonged over there. It just shows them which way they've gone. It doesn't matter which way you do it as long as you draw crosses for one atom and dots for the other. So beryllium is given away 2 negatives. It's lost 2 negatives. So that now makes it plus 2. And we do have to write the 2 this time because it's plus 2. And then oxygen minus 2. So plus 2, minus 2. They hang around together. That's now beryllium oxide. The last thing to go into for ionic bonding is what happens when the charges aren't equal. So if I look at lithium and oxygen, and we've drawn both of these before. So lithium, and you can rewind the video if you want to see it. Lithium's got 3 electrons and it's in group 1, so we know it's got 1 on its outer shell. And oxygen has got 8 electrons and it's in group 6, so it's got 6 on its outer shell. Okay. So oxygen wants to gain 2, but lithium's only got 1 to give away. So we do what we normally do. So we've done that. We draw our square brackets. We write a plus. I will put plus 1. It's not wrong to write plus 1, but if you only see it as plus, it means plus 1. So we've got lithium, and that electron's gone over here. But oxygen's not happy yet. It's not stable. It needs an extra electron, but lithium hasn't got an extra one to give away. So what we actually do is we need another lithium. So we have 2 lithiums. This one gives 1 to oxygen, and this one has given 1 to oxygen. But rather than going to the hassle of drawing out 2 lithiums, we just put a little 2 at the bottom to show that there's 2 of them. Now we can draw our square brackets around our oxygen and put minus 2. And how do these charges balance out? Well, we've got minus 2 and we've got 2 lots of plus 1. So 2 lots of plus 1 makes plus 2, minus 2, they cancel out. So if we were writing that as a compound, you would put Li2O to show that there's 2 lithiums. And the final example for ionic bonding, if I do beryllium and fluorine, so you look at your periodic table. So beryllium is in group 2 with 4 electrons. Fluorine is in group 7. It's got 9 electrons. So we know beryllium 1, 2, 3, 4. We've got fluorine. We know it had 9 from the periodic table. We know it was in group 7, so 7 on its outer shell. Okay, so this one goes to there. Okay, but beryllium's got 1 more to give away, and fluorine's got no space to put it, so we need another fluorine. So we have another fluorine here. 1, 2. So we've got 2 fluorines. Beryllium gave away 1 to this fluorine and 1 to that fluorine. But again, scientists are lazy. We don't like drawing things we don't have to. We don't have to. So we don't draw any of that. We don't draw the second one. How we would draw that is we've got our beryllium, we put our square brackets around it. It's given away 2 electrons, so it's plus 2. We've got our fluorine, we put our square brackets around it. It's got minus 1 because it's gained 1, and we needed 2 of them, so we put the 2 at the bottom to show that there's 2 lots of minus 1, two lots of this. So two lots of -1 makes -2, -2 and +2 cancel out. And that's, in a nutshell, ionic bonding. And ionic bonding happens when you've got a metal, from this side, this is supposed to be the periodic table, when you've got a metal and a non-metal, because metals are losers. Metals have got too many electrons, so they want to lose an electron. Non-metals don't have enough, so they want to gain them. So if you have a metal and a non-metal, the metal loses its electrons and the non-metal gains the electrons. So that's ionic bonding, metal and a non-metal. Now we're going to talk about covalent bonding. Covalent bonding is only involving non-metals. They don't have enough electrons. So what they do is they share. So two non-metals get together, neither of them have enough electrons, so they decide to share them. And what that looks like, so if we have hydrogen, hydrogen's got one electron, it's the simplest atom. One thing I'm not happy with on this periodic table, it was the best picture I could find for this video, but I'm not happy with the fact that hydrogen's in the metal section. In the periodic table you get on your exam, hydrogen's over here. So we consider hydrogen to be a non-metal, so it's the only one that doesn't really fit that pattern. Hydrogen, it's got one electron. And then another hydrogen here, it's got one electron. And so what they decide to do is come together and share those electrons. And so any electrons that you draw in this little overlapping bit are shared. So now this hydrogen's got 2 electrons, which is a full shell. Remember, it's the first shell, it can only fit 2 electrons in. So 2 electrons at full shell. This one, 2 electrons, it's a full shell. So covalent bonding is when they share a pair of electrons. I'm going to show you a few more examples of that. So chlorine, periodic table, chlorine is in group 7. It's got 7 on its outer shell. I'm only going to draw the outer electrons here. It does have the shells inside. I'm not going to draw them to make it quicker. So chlorine, it's got 7 on its outer shell. 1, 2, 3, 4, 5, 6, 7. And it shares. So we've got another chlorine there. 1, 2, 3, 4, 5, 6, 7. Oops. They are sharing a pair of electrons. That is Cl2. Sharing a pair of electrons. So they've both got 8 in their outer shell, and that's what makes them stable. Couple more quick examples of this. So water, it's H2O, but why is it H2O? It's got 2 hydrogens and 1 oxygen. If we draw our oxygen, oxygen is in group 6. You can look up on your periodic table. 1, 2, 3, 4, 5, 6. That's our oxygen. Hydrogen, we've already drawn these earlier. H, there. H, there. So now oxygen has got 1, 2, 3, 4, 5, 6, 7, 8. Nice stable outer shell. And hydrogen's got 1, 2. This hydrogen's got 1, 2. Nice stable outer shell. Remember the rule, 2, 8, 8. So you fit 2 on the first shell. So the first shell's got 2, stable. First shell's got 2, stable. Oxygen is outer shell 1, 2, 3, 4, 5, 6, 7, 8. I haven't drawn, because oxygen has another shell in there. I didn't draw it to me because it makes it a bit more complicated. You only, with covalent bonding, you only need to worry about drawing the outer shells, but the inner ones are still there. So that's water. And the last example for covalent bonding is something that's called a double bond. So a single covalent bond is sharing a pair of electrons, which means a double covalent bond is sharing 2 pairs of electrons. So if I look at O2, oxygen, you're breathing it in now. So 1, 2, 3, 4, 5, 6. So that's oxygen. It's in group 6, so it's got 6 on its outer shell. Then we've got another oxygen here. 1, 2, 3, 4, 5, 6. So this one's now got 1, 2, 3, 4, 5, 6, 7, 8. And this oxygen's got 1, 2, 3, 4, 5, 6, 7, 8. So this is a double bond because they are sharing 2 pairs of electrons. So in an ionic bond, it's gaining and losing electrons. It's a metal and a non-metal. Metals got too many, non-metals don't have enough. So they form ions, positive and negative. In a covalent bond, it's 2 non-metals and neither of them have got enough, so they share. So summary for today, atoms with a full outer shell are more stable, so they try to get the full outer shell. Remember, 2 on the first, then 8, then 8, then 8. If you've got a metal and a non-metal, it makes an ionic bond, because metals are losers. Why are they losers? They've got too many electrons, so they want to give one away. Non-metal, not enough electrons, so they want to gain them. So that means these become positive, these become negative. It's an ionic bond. Covalent bond. Non-metals don't have enough electrons, so when you've got two things that don't have enough, they share them. So a covalent bond is sharing a pair of electrons. Ionic bond, gaining and losing electrons. Covalent bond, sharing a pair of electrons. Hopefully that's helped. Have an average day.